Okay, students, today we're going to talk about the unit circle and how two special right triangles are going to allow us to create the unit circle. So we're going to answer some of these as a warm-up here, and feel free to follow along in your packet. You can do these and just pause me and then check your answers, or you can work along with me. Either way is fine. So how many radians are in a full circle? So if you watched the video with the Skittles, Taste the Radian, you remember that there are, oops, yellow is not the best color. Let's try pink. There are 2 pi radians in one complete rotation. And then in a half circle would just be 1 pi radians. Okay, how are radian measures corresponding with these following degree measures? So we want to know how many radians is 30 degrees, 45 degrees, and 60 degrees. So let's kind of think about this here. If this is pi, and this is 0, here's where we're going to start. That means this right here would be half pi radians. And we know that this is 45 degrees. So that means this is going to be pi over 4. So I started with that one. Pi over 4 radians. Okay, so now let's think about that 30 degree. Let's say that's somewhere around here. So this 30 degree, let's see, how many 30 degrees are in quadrant 1? Oh my goodness, sorry. So in quadrant 1, we have 1, 2, 3 of them, right? 30, 60, 90. So that means this should be, if that's 3 here, there's another 3 here to make that full pi, okay, to make that half circle. So that means this has to be pi over 6. So that's the 30 degree angle. So this is pi over 6. And then let's think 60 degrees. So we know that this is 180 degrees. So let's think about for 60, there would be 3 of them in here. So if we want to think about the 60, let's say maybe it's like here, here. This is terrible drawing. So there's 1, 2, and 3 of them. So that means that 60 degrees here would be pi over 3. I'm not having good luck today. I don't know what I'm touching to keep doing that. Okay. Pi, oh my goodness. Let's just write it right here. Pi over 3. Okay. So those are the angles, are 30, 45, and 60 in our special right triangles. And of course, a 90 degree angle as well. Okay, what is a reference angle? So let's go ahead and let's see if I can hit that button, whatever I'm hitting a bunch more times. So a reference angle is the angle formed by the terminal side of the given angle and the x-axis. You might want to also note that it's always a positive acute angle. So angle pi over 6 is called a reference angle for all of the 4 angles shown. So here's pi over 6. If this is the first angle, this is the terminal side. So the terminal side makes an angle with the x-axis of pi over 6. Okay, now let's look at what happens with this next one. Here's the angle that we have of 5, 6 pi, 5, 6 pi. Now we're looking for the terminal side. This is the terminal side and the x-axis. And this is again pi over 6 for the reference angle. Okay, now we're going to do the same thing with 7, 6 pi. We're going to go all the way around here to 7, 6 pi. Here's the terminal side. And we're looking for this little angle here with the x-axis. Again, pi over 6. And then I'm sure you can't guess what's going to happen with this next one. We're going to go all the way to 11 sixth pi. Here's the terminal side. Here's that little baby angle with the x-axis. It's pi over 6 again. So you should notice that all four angles are congruent. They're all pi over 6. Now, it says draw four angles associated with the reference angle for pi over 3. So I'm going to let you try this. And if we have 1/3, then we're looking at something like this. So this would be pi over 3. This would be 2/3 pi. This would be 4/3 pi. And this would be 5/3 pi. Again, if we went all the way around, this is 6/3 pi or 2 pi, right? And this one is 3/3 pi or 1 pi. So we have all the thirds. In total, if we want to go a full revolution, there would be 6/3. So reference angles. We're looking here. We're looking here. We're looking here and here. So the angles that have the reference angle of pi over 3 are the following. Pi over 3, 2/3 pi, 4/3 pi, and 5/3 pi. Okay, so those are the four angles in that one rotation. There's more angles that would still give you a reference angle of pi over 3. But in a single rotation from 0 to 6/3 pi, these are the four that would have that same reference angle. Okay, the next part here is saying, what do you think the reference angle is for 5/4 pi without drawing a diagram? So look at 5/4 pi. We know that 4/4 is 1 pi. So we're going just over 1 pi. So how much over am I going? 1/4. So the reference angle is going to be pi over 4. So if you want to think about that, and I know it said don't draw it, but we're basically taking 5/4 pi and we're subtracting 1 pi. So we can write we're subtracting 4/4 pi. And that'll get us this little piece right here. Okay, so we can do that subtraction to find that reference angle. Okay, so the next thing we're going to do, and I'm going to stop the video here so I can record how I'm doing this, but we are going to create the unit circle, and we are not going to memorize the unit circle. So I've had students in the past and they have everything memorized and they recreate that unit circle and it takes up so much time and is not necessary. What you need to know is your two special right triangles. If you know those two triangles, you can get anywhere on that unit circle with these special spots we're going to be looking at. Okay, so you're going to cut out the triangles from the bottom of the page and label the angles in radians and degrees, both inside the triangles, or you're going to put them inside the triangles, the little measurements, and on both sides. So flip it over and put it on both sides. Label all side lengths with exact values, no decimals. You want to reference your special right triangle graphic organizer, and you're going to label it just like we did there. And then let's see here. We're going to place the triangles on the circle in different locations and start labeling. So do not cut out the circle. Only cut out the triangles. And I'm going to go ahead and do a video of showing how we're getting to that unit circle.